Next one is ultraviolet. Ultraviolet rays are not visible to us. They're beyond our visible limits. If we remember, our prefixes infra meant below and ultra meant above. So this is above our visible seeing range. It goes from 60 to 400 nanometers. Bumblebees can see ultraviolet light. They have a lot of flowers have little honey guides in there that are markings in ultraviolet. And if you can look at a flower under ultraviolet light, it looks something like this, and you can see where the honey guides are for the bees. I also have some stories to tell about this if somebody reminds me in class. Sunburn and skin cancer are caused by ultraviolet light. Too much exposure to it is a very bad thing. I saw this picture on the internet I put on there. It's kind of funny. Your body tans because it's trying to protect itself from the ultraviolet rays. Ultraviolet rays are damaging to us. They cause sunburn, skin cancer, and your body tries its best to protect itself. The more you're exposed to them, the darker and darker you will get. Pause and copy. X-rays are next. X-rays are 60 nanometers to 0.1 nanometers. And we're familiar with X-rays for the dentist getting your teeth X-rayed. With the X-rays, they are so small and have such high energy that they are going right through your skin and muscles, but they cannot go through bone and teeth. Like I mentioned before, in a regular photograph, what's happening is we're shining light onto the person reflects the light back to the camera, and then it goes onto the film to make our picture. For the X-rays, we are sending the X-rays through the person. They go through your skin and bones, and then over on this side, they put that thing in your mouth that has the plate for the film inside of there. So for X-rays, these rays are going through your skin and muscles, but not through the bones that allow us to see the bones in the teeth. X-rays are dangerous. Obviously, if they're going through your body, it's not good for you, and you're limited on how many X-rays you can have during a year. If you ever noticed at the dentist, when you go, the dentist sets up the machine and then he leaves the room because he can't be exposed to all those X-rays. They are very dangerous to us. Pause and copy. Last one is the gamma rays, 0.1 nanometers. They call it 10 to the minus fifth nanometers, but that doesn't make sense. Nano's 10 to the minus 9, so if we do 10 to the minus 14th, move the decimal over once, we get 10 femtometers. These rays, as we're going this way on the spectrum, they get more and more energy to them. Gamma rays have a very high energy, and that means they're extremely dangerous to us. These gamma rays will go through not only your skin and muscles, but it will go through your bones as well, and they will kill any cells that they go through. Right? We use gamma rays to irradiate food. This will kill any bacteria that's on the food. We use gamma rays for cancer treatment. Radiation therapy, they're zapping your cancer cells with gamma rays. Unfortunately, it also kills other cells as it goes through your body, and the people end up getting sick from it. We've also found out that gamma rays come from black holes. As things go into a black hole and the black holes form, they give off gamma ray bursts. Pause and copy. Inverse square law is our next topic. Light, electromagnetic waves, sound, gravity fields, magnetic fields all decrease with the square of distance. Our intensity formula that we don't need to know is power divided by area. And this is where the inverse square law comes from. If we compare a 100-watt light bulb at 3 different distances to look at our intensity, we can demonstrate the inverse square law. So here's our light bulb. That light comes out in all directions. We imagine a sphere of light coming out. So the area that we're going to use is the surface area of a sphere. So we do power divided by the area, and this is where the square in the denominator comes from for the inverse square law. So if I look at 1 meter, 2 meter, and 3 meters, you can see that when I put the 2 in the formula, it's going to get squared and make this 1/4 as bright as this one is. If I put the 3 in the formula, the 3 gets squared and makes it 1/9 as bright as this one. This is called the inverse square law. This is a picture diagram of how it works. If we look at the amount of light rays passing through this little box here, and we move out 1 more meter, those light rays are spread out over 4 boxes. So each one of these boxes has 1/4 of the intensity of this because it's spread out 4 times. If we go out 3 meters, then you can see it's stretched out 9 times. So each one of these 1 boxes has 1/9 of the light that was coming through this box because it's being spread out. And this will be our last pause and copy.